assume in the illustration below you start at the bakery. So your bakery is your starting position, and that's going to be your 0, right? That's your 0. Okay. Travel to the cafe, then the art gallery. So first you travel to the cafe, and the cafe seems like 4 kilometers away. Okay. So this is your first trip all the way to cafe, and you travel 4 kilometers. Then you travel to the art gallery after the cafe, and then you travel this much. But how much did you travel from cafe to the art gallery? It's 6.5 kilometers. Okay? So, the whole entire trip takes 45 minutes or 0.75 hours. So A, calculate your average speed in kilometers per hour. Well, we all know average speed V, so for part A, average speed V is distance total divided by time total, right? So we already know the distance total is 4 plus 6.5, right? So it's simply 4.0 plus 6.5, right? Kilometers. Divide that by total time, which is 0.75 hours. And if you use that calculator, you're going to get 14 kilometers per hour. So that was pretty easy, right? And then for part B, they ask, calculate your average velocity. Well, for part B, your average velocity is simply the change in position, right? Change in position. Or your displacement divided by delta t. Your displacement is simply final position minus the initial position, and delta t, of course, is your total time, right? Because you're starting from here and it took total time to get here. Therefore, your final position happens to be negative 2.5 kilometers x hat, right? So negative 2.5 kilometers, right? X hat, right? Minus your initial position is 0. Whole thing divided by 0.75 hours. Therefore, when you work this thing out, you're going to get negative 3.33 kilometers per hour. Was that okay? That was easy, right? Come on. That was... All right, good. Let's move on to the second one. So a car travels 80 kilometers east. All right? So make sure you know your cardinal points here. All right? So I'm just going to just quickly label, all right, what... So here's your north, right? This is your north, and this is your east, right? Therefore, if the car travels 80 kilometers east, so we're going to start here, so here's our 0, and we're going to travel 80 kilometers east. Now you don't have to draw this in scale, but I like to, just to make sure that I'm visualizing this correctly. So I'm going to say each centimeter is 10 kilometers, so 80 kilometers east, right? The people driving realize they went too far, and they turn around and travel 55 kilometers west. So now they turn around and they go back 55 kilometers. So this is where they are now. That's the final position, right? So this is 55 kilometers west. So here's the final position right here, which is what? What is that? 2.5 kilometers, right? So 2.5, 25 kilometers, right? East, right? So positive 2.5 kilometers east. Therefore, we can now say, the change in position is equal to simply positive 25 minus 0, right? Is that. So this is your delta x. Okay? And your delta x is from here to here. Alright, so let's take a look at part A. Part A, it basically takes 2.5 hours for the total trip. Calculate the average speed. So for part A, average speed V is equal to D total divided by T total, which is simply 80 plus 55 kilometers, whole thing over T total, which is 2.5 hours. So if you do that math correctly, you should have gotten 54 kilometers per hour. But for part B, they want to calculate your average velocity. They want the average velocity, which is equal to, right, change in position divided by change in time, which is x final minus x initial divided by t total. Therefore, it looks like final position happens to be positive 25 kilometers, or x hat, okay, or east, right, minus 0. Whole thing over 2.5 hours. So if you work that out, you're going to get positive 10 kilometers per hour. Now you could call it x hat or you could call it east, the same thing, right, in this case. And that should be fine. Alright. Are we good so far? Yeah? Now comes trouble. Right? Now comes trouble. So here, we have two objects are traveling in the same direction. A car traveling 98 kilometers per hour, and it is 0.21 kilometers behind the truck traveling 81 kilometers per hour. So you're driving on the highway, and here's the starting position. Okay. Here's the starting position, right? So this is your 0, and here's your car. Here's a car right here. Your car, right? So this is car, and the speed of the car is going at 98 kilometers per hour. V car is equal to 98 kilometers per hour. There's a truck, and it's behind the truck. That's the truck, right? And car happens to be 0.21 kilometers behind the truck. So the truck is 0.21 kilometers ahead of the car. And truck is traveling at 81 kilometers per hour. Now they're both going to be moving in the same direction. So what's going to happen eventually? What's going to happen? When the car's speeding up, it's going faster than the truck, so eventually, right? If they're right next to it, yeah, they're going to start to overtake the truck, right? So they want to know when that will happen. When will the truck and the car be at the same spot? Right? So car and truck, right? So this is the final position, okay? This is the initial condition. This is the initial condition for the truck, all right? So the distance that car travels, right? And the distance that truck travels are going to be different, but the distance for the car is same as distance of the truck plus that 0.21 kilometers. Does that make sense? Right? So you can see that distance for the car travels is same as, right, distance for the truck plus 0.21 kilometers. Can we all see that? Yeah? So this is good to know, right? This is good to know. Oops. So we will separate the car and the truck and see what we can find. For the car, we know speed of car is distance of car divided by the time. The time is going to be the same. Time is common for both truck and the car. And we also know that V for the car is simply 98 kilometers per hour is equal to distance car divided by the time. At this time and this time, same time. So here's one equation, but we have two unknowns. We don't know the distance of the car. We don't know the time. Let's take a look at the truck. The speed of the truck is equal to distance of the truck, right? Divide that by, right? Divide that by time. So we know the speed of the truck is 81 kilometers per hour, but distance for the truck, if we were to solve for the distance for the truck, right, that is same thing as distance car minus 0.21 kilometers. So this is something we can use and plug that into here. Okay? So why don't we plug that into here? Then we can say that distance truck is, right, distance car minus 0.21 divided by the same time t. This t and this t are the same. So here's our equation 2. So now we can just solve for one of them and then plug it into the other and solve for the other variable that we don't know. So let's take a look at the equation 1, which is the car. If we solve for the distance car, that is equal to simply 98 times the time t. Alright? Then we can put this into here. That means we can say, right, 81 now is equal to, right, distance C is 98 t minus, right, 0.21. Whole thing over the time t. Well, if I multiply both sides by time, this time goes away, and I would have 81t here is equal to, right, 98t minus 0.21. Right? So if I bring this negative to the other side of the equal sign, it becomes positive. And then bring this by subtracting 81t to both sides, and I get 17 on this side. So my time t is equal to 0.21 divided by 17. That is equal to simply 0.0124 hours. Well, they want it in seconds. So we should multiply this by, there are 3,600 seconds in 1 hour. Right, so hours get canceled out nicely. And if you work that out, this becomes 44 seconds. So the time t is equal to 44 seconds. All right. It took a little, extra steps here and there, but I think it was manageable. All right. I'll stop there for today, and then you need to work on the other page. All right.